Welcome to this FP2 video on the method of differences. So we can use the method of differences to find the sum of a finite series. So just in terms of notation and algebra, if I have a series between 1 and n and it is some value of r, some general term, then usually I can create an equivalent one which will be like a function of r minus a function of r plus 1. Okay, and then what that generally means is for the first term, so if I substitute the first term into this side, I get f of 1 minus f of 2. And when I substitute the second term in, I get f of 2 minus f of 3. And when I substitute the third term in, I get f of 3 minus f of 4. And what I get is that these start cancelling. So f of 2, a positive one and a negative one, well, these two cancel. And then, a positive f of 3 and a negative f of 3, these two cancel. And I keep on going all the way down to un, where I've got f of n minus f of n plus 1. And each of these are going to cancel all the way down. Yeah, so like the 4 will cancel with the 4 all the way down to like the f of n will cancel with the f of n. Okay, leaving me, if I cancel that one there, leave me in the end of f of n, f of 1 minus f of n plus 1. So it leaves me that the sum of this is simply f of 1 minus f of n plus 1, because all the terms in between this one and this one have cancelled. So it's just leaving me with these two. And then I can just stick these values in and I can get the sum of this general term. So that's kind of how it works, in terms of algebra. It's maybe not as easy to follow when we look at it like that. So I think what we'll do is we'll look at it with actual values in a few examples. Okay, so this question is gonna be in kind of two parts. The verify bit first. So let's do that. That's not a method of differences, but the second part of the question here is. So first of all, I've got 1 over r squared minus 1 over r plus 1 squared. And I need to make them over r squared, r plus 1 squared. So that's going to be r plus 1 squared minus r squared on the top. So that is r squared plus 2r plus 1 minus r squared on the top, and r squared r plus 1 on the bottom squared. And the r squareds will cancel, leave me 2r plus 1 over r squared r plus 1 squared, which is what we required. So I'll just stick that up there just to give myself plenty of room. So that's the first bit done. Now I need to look at the second bit, the method of differences. So what we have is we have this sum between 1 and n of 2r plus 1 over r squared r plus 1 squared. Now that's going to be the same as the sum of r equals 1 to n of 1 over r squared minus 1 over r plus 1 squared. Okay, because we've shown that this equals this, so the sum of this equals the sum of this. And this is now where the method of differences comes in. So let's start with let r equals 1. Then we've got 1 over 1 squared minus 1 over 2 squared. Okay, and for this I'm going to keep it just with the squares. I'm not going to, 2 squared is 4. I'm not going to get rid of that squared. Okay, because it makes more sense as you go through to leave those in, because you can see a pattern. Now when r equals 2, we got 1 over 2 squared minus 1 over 3 squared. When r equals 3, we got 1 over 3 squared minus 1 over 4 squared. And I think you can see a bit of a pattern appearing here. So we've got a positive 1 over 2 squared and a negative 1 over 2 squared. Those are going to cancel with each other. We've got a positive 1 over 3 squared and a negative 1 over 3 squared. Those two are going to cancel with each other. And we're going to go all the way down to r equals n. And this will be 1 over n squared minus 1 over n plus 1 squared. And as you can see, if you follow the pattern, it's going to be this one cancels with the one below it at the start. So, up here will be a 1 over n squared, cancelling with this 1 over n squared. So what I'm left with is this one and this one. Okay, because everything else cancels. So I can say that this equals 1 over 1 squared minus 1 over n plus 1 squared. And then we want to simplify it, because we've got 1 minus 1 over n plus 1 squared, which will be, if I turn this 1 into an n plus 1 squared over n plus 1 squared, I get n plus 1 squared minus 1 over n plus 1 squared, which is n squared plus 2n plus 1 minus 1 over n plus 1 squared, which is n squared plus 2n over n plus 1 squared, which is n plus 2 over n plus 1 squared. And that's it simplified. So the sum of this is just this expression here. Okay, so if you've got another value, so you've got like a part B, part C of this question, you've got it given a value here for n, you can just use this to find out the sum. Okay, very, very easy. But anyway, so that's that one. Let's have a look at another example. So here's my first example. It's actually a past paper question that we're going to have a go at. So first part, show that r plus 1 cubed minus r minus 1 cubed is 6r squared plus 2. So let's expand r plus 1 cubed. That's going to give me r cubed plus 3r squared plus 3r plus 1. Then minus, now expanding the r minus 1 cubed gives me r cubed minus 3r squared plus 3r minus 1. So we got r cubed plus 3r squared plus 3r plus 1. minus r cubed plus 3r squared minus 3r plus 1. So the r cubes cancel, the 3r's cancel, and this leaves me with 6r squared plus 2, which is what we were requiring. So that's the first part, and that is not the method of differences. Now part B is when we're going to be using that method of differences. Okay, so let's look at how we're going to set it up in this scenario. So for this, we're just going to start off with this section here. Okay, so we're looking at the sum between r equals 1 and n of r plus 1 cubed minus r minus 1 cubed. That's what we're going to look at. Okay, so when r equals 1, we're going to have 2 cubed minus 0 cubed. When r equals 2, we've got 3 cubed minus 1 cubed. When r equals 3, we've got 4 cubed minus 2 cubed. When r equals 4, we've got 5 cubed minus 3 cubed, and so on. Now you can see a bit of a pattern come in here. So this 2 will go with this 2 here. This 3 will go with this 3. Okay, and I can keep that pattern going. But what I've got to look for is what doesn't cancel. Okay, so 2 here on the right hand side won't cancel, which means that when I get down to the bottom, it'll be 2 on the left that don't cancel. So n minus 1 would give me n cubed minus n minus 2 cubed, and then n will be n plus 1 cubed minus, and then this will be n minus 1 cubed. Okay, and they'll all cancel all the way down, and it'll leave me with, like, these will cancel with previous ones, and it'll leave me these 2 here. Okay, because what you'll always have, there'll always be a pattern. So, you know, if you've got the 2 on the right hand side that don't cancel, it'll be the last 2 on the left hand side that also don't cancel. If you had, say, these 2, the 2 on the left that didn't cancel in the beginning, you'd have the 2 on the right that don't cancel at the end. If you've got 1, then it's just the 1 at the end. So that's like the pattern that you've got to be able to get used to and spot. Okay, so this means it's going to be, sorry, I'll put this back in black, n cubed plus n plus 1 cubed minus 0 cubed minus 1 cubed, or n cubed plus n plus 1 cubed minus 1. Okay, so that's what I've got so far. Now this is equal to this. So this then for equals the sum of 6r squared plus 2. Okay, so if I want the sum of r squared, so that'll be 6 sum of r squared. Now if I take this 2 to the other side, so it's at the moment it's going to be plus the sum of 2. So that's what we've got. So I take that sum of 2 to the other side. So that gives me n cubed plus n plus 1 cubed minus 1 minus, and then the sum of 2 is 2 times the sum of 1, isn't it? 6 sum of r squared. And the sum of 1 between 1 and n is just n. So this gives me n cubed plus n plus 1 cubed minus 1 minus 2n equals 6 sum of r squared. Now let's expand my brackets. So this is going to be n cubed plus 3n squared plus 3n plus 1 minus 2n equals 6 sum of r squared. So now my 1's will cancel with each other. And I'll just write the 6 sum of r squared on the left hand side now. So that is 2n cubed plus 3n squared, and then 3n minus n is plus n. Okay, equal, I've already done the equals. Now let me just move my page up. Now we can factorize out an n, leaving me 2n squared plus 3n plus 1. And then this will factorize hopefully into 2n and n. And this is a 1 and a 1 plus and a plus. So that's 2n squared plus 2n plus n is plus 3n, and this is plus 1. Now we're almost there. Divide by 6, and we get 1/6 n, 2n plus 1, n plus 1. And just to show you, here it is. 1/6 n, n plus 1, 2n plus 1. And that is what we've got here. 1/6 n, n plus 1, 2n plus 1. Okay, and that's using the method of differences, this section. So if it gives you part in there, you will start with that to simplify it, and then put it equals to like the bit in the question, the expression that you made equals to. So there's sometimes a little bit of manipulation needed. Okay, not always going to be just a straightforward method of differences. Next, we'll have a look at another example. So in this example, we are dealing with partial fractions. So A is just express this in terms of partial fractions. So I think this, you should all be pretty much aware of how to do this. So I'll run through it quite quickly, but you should be more than capable of doing the partial fractions now. So when r equals minus 4, we get 2 equals 0 plus minus 4 plus 2 is minus 2, so minus 2b. So b equals negative 1. And when r equals minus 2, we get 2 is equal to 2a plus 0, so a equals 1. So as a partial fraction, we've got 2 over r plus 2, r plus 4 is equal to 1 over r plus 2 minus 1 over r plus 4. Okay, and this is what we're going to use. This is what's going to be important. Okay, for part B. So part B now is basically where we use the method of differences. So part B is our sum of 2 over r plus 2, r plus 4. And this is going to be equal to the sum of 1 over r plus 2 minus 1 over r plus 4. Now we substitute our values in and look for our pattern. So substituting 1 in, we get 1 over 3 minus 1 over 5. When I substitute 2 in, I get 1 over 4 minus 1 over 6. When I substitute r equals 3 in, I get 1 over 5 minus 1 over 7. When I substitute r equals 4 in, I get 1 over 6 minus 1 over 8. And you can start to see the pattern building up here. That fifth will go with that fifth, that 6 will go with that 6. So we've got 2 here on the left that are going to remain untouched. So when we go down to the bottom, we're going to have 2 on the right, which will also remain untouched. So let me just move that up a little bit. Just trying to keep it in. So we want the last 2, so that's going to be n minus 1 and r equals n. So those are the final 2. So n minus 1 plus 2 will be n plus 1 minus n minus 1 plus 4 is n plus 3. And then we've got 1 over n plus 2 minus 1 over n plus 4. And it's going to be now these 2 on the right. Okay, so everything else will cancel. So this is cancelling with the third one down, this one's cancelling with that one down, this one's cancelling down, and it'll go all the way down to there, but there won't be any to cancel with these. So now what we can do is we can say, right, the sum of 2 over r plus 2 r plus 4 is equal to 1/3 plus 1/4 minus 1 over n plus 3 minus 1 over n plus 4. Okay, and now what I want to do is I want to basically get it as a single fraction with n plus 3, n plus 4 on the bottom. Okay, and then the 3 and the 4 is also going to be in there, and that's what's going to make the 12 here. So this is going to be 4 n plus 3 n plus 4 plus 3 n plus 3 n plus 4 minus 12 minus 12. And that then will all be over 12 n plus 3 n plus 4. So hopefully you're able to follow this, just putting it as a single fraction. So it's over 12 n plus 3 n plus 4, which means for this I'd have to times by 4 n plus 3 n plus 4. For this I'd have to times by 3 n plus 3 n plus 4. For this one I'd have to times by, oh sorry, it's not just 12. Let me make a little bit of room. So it's 12 n plus 4 minus 12 n plus 3. Sorry, I just put 12 and 12 then, forgetting the bottom ones. So now what we've got to do is we're going to end up with this 7n squared plus 25n. So we want to expand now and simplify. So I've got 4. Now this is going to be n squared plus, now it's 4 and 3, so 7n plus 12 plus 3 times that. I suppose I could have put that as a single fraction. First of all, you know, 1/3 plus 1/4 is 7/12, which is, you know, what I'm looking at here. So I could have really done that straight away. 12 times 4 is 48. And it's 12n. Okay, sorry, just skipping ahead slightly there. So now we've got 7n squared plus 7 times 7, 49n, plus 84, minus 24n, minus 84, over 12, n plus 3, n plus 4. So this is 7n squared plus 25n. The 84s cancel with each other. So now we've got what we were aiming for. And that there is the method of differences. Now, before we move on to the questions, I just want to show you a little something that can help you when you're finding the patterns. So you can do this without finding the patterns, just by purely what's in your question. So you know this was split into this one, as in the last question. And if I said let FR equal that 1 over R plus 2, then what I've got is the sum of FR minus F of R plus 2, because this R plus 4 is R plus 2, isn't it? So if FR is R 1 over R plus 2, F of R plus 2 is R plus 2, which is R plus 4. So I've got this, okay? Now, if I've got this, then because there is two difference, so R is not next to it, R plus 1, it's an R plus 2, then that means I'm going to end up with F of 1 plus F of 2 minus F of n plus 1 minus F of n plus 2. Which then, if you go back up to the F of R, if you substitute 1 into this, it's 1 over 3, plus substituting 2 in, that's 1 over 2 plus 2, which is 1 over 4, minus now n plus 1, so that's n plus 1 plus 2, so that's 1 over n plus 3, minus, and now it's n plus 2, so 1 over n plus 2 is 1 over n plus 4, which is what we ended up with in the previous question. Okay, so it's a little bit of a shortcut, or certainly you can use it as a way to kind of check your answers. And this is the first example I give, and look at this, R and R plus 1, they're next to each other. Okay, so if I said in this case let F of R be 1 over R squared, then the sum now becomes F of R minus F of R plus 1, which becomes F of 1 minus F of R plus 1. So again now substituting in 1 over 1 squared minus 1 over R plus 1 squared. Which is exactly what we got when we looked for the pattern. So this is just a way of, you can use it to check, you can use it to do it. Personally, I prefer to look for the pattern, but if the pattern isn't obvious, you could use this method, okay, where you're letting, you know, your F of R be like for this one, for example, and then look for the pattern. So this is like R plus 1. Okay, so hopefully that makes a little bit of sense, but if not, don't worry about it, just stick to how I did it in the examples. Now, if you found this video useful so far, hit that like button. If you're yet to subscribe, hit the subscribe button, and if you're willing and able to help me out financially, hit that join button. Otherwise, let's get stuck into the questions. So 4 questions for you to have a go at. I've tried to vary them. They are all past paper questions, you know, so there's that, but there's plenty in your textbooks to have a go at. So have a go at these 4, check your answers afterwards, and then if you want some further ones, jump into your textbook or go online. You all know the places to get questions. Otherwise, let's pause it here. Okay, hopefully you've had a chance to have a go at these 4 questions. Let's now go through them. So this first one gives it to me, so I don't have to do any kind of working out. So r plus 1, r plus 2 is equal to the sum of 1 over 2 r plus 1 minus 1 over 2 r plus 1 r plus 2. Okay, and I'm going to look for the pattern rather than, you know, I could use that form because we've got r and r plus 1, and then we've got, oh sorry, that should be a 2 there, r plus 1 and r plus 2, so there's 1 out from them. But anyway, let's look for the pattern. So this is 1 over 2 times 2 minus, oh, let me write this out actually in full. So 2 times 1 times 2 over 1 over 2 times 2 times 3. Okay, now I'm not working out those values. I can work them out, but sometimes you miss the pattern when you do that. Okay, so this is 2 times 2 times 2 minus 1 over 2 times 3 times 4. So this is 2 times 3 times 4 minus 1 over 2 times 4 times 5. And I got to 4, 1 over 2 times 4 times 5 minus 1 over 2 times 5 times 6. And you can see the pattern that is emerging here. Sorry, I've made a mistake here. This should be a 3. Yeah, so there's the pattern emerging. This one with this one, this one with this one, this one with this one, and like this one will go with this one down here. Okay, just you know, getting rid of that a moment. So now what I can do is let me just move this up out of the way a little bit, give myself a little bit more room. So I need now, because I've just got the first one, I just need the nth term. So it's 1 over 2n n plus 1 minus 1 over 2n plus 1 n plus 2. And of course, this is going to cancel with one that's there, and it's going to leave me the first one on the left and the last one on the right. Okay, so that there is my solution. So the sum of 1 over r plus 1, r plus 2, between 1 and n, is going to be 1 over 2 times 1 times 2 is going to be 4, minus 1 over 2n plus 1 n plus 2. Now all I've got to do is put this together into one fraction. And this is going to be over 4 n plus 1 n plus 2. So this is n plus 1 n plus 2 minus 2, isn't it? Okay, because I'm going to times this fraction top and bottom by 2 to get this, and times this fraction top and bottom by n plus 1 n plus 2. So that's going to be n squared plus, now 2 and 3, n plus 2 minus 2 over 4 n plus 1 n plus 2. Now obviously the 2's we're going to cancel with each other, and I can factorize out an n, so we've got n plus 3 on the top over 4 n plus 1 n plus 2. And that there is now it done for the method of differences. Now let's have a look at question 2. So first part is express as partial fractions. So that's going to be a over r plus b over r plus 2, which is going to be 1 a r plus 2 plus b r, when r equals 0, 1 equals 2a, so a equals a half. When r equals negative 2, 1 equals 0 minus 2b, so b equals minus 1/2. Okay, so 1 over r plus 2 is equal to 1 over 2r minus 1 over 2r plus 2. Okay, because that's the half being put in here. So that's part A done, and we're going to use this now in our part B. So I've written down obviously the sum and then what the equivalent of it is in terms of the partial fractions. And now let's look for our pattern. So substituting 1 in, we get 1 over 2 times 1 minus 1 over 2 times 3. So this one, remember there's 2 difference between them, r and an r plus 2. So there's 2 difference, so we're expecting 2 from the top and 2 from the bottom. So 1 over 2 times 2 minus 1 over 2 times 4. R equals 3. 1 over 2 times 3 minus 1 over 2 times 5. And we've already now started picking up the pattern. I'll go to one more. 1 over 2 times 4 minus 1 over 2 times 6. And here is the pattern there. The 3's will cancel, the 4's cancel, and then we'll go on to the 5's and so on. So we've got these 2 in the beginning, which means that we're going to have 2 at the end. Okay, so let me just move this up. So since I want the last 2, I want when n equals 1 and then when r of equals n. So that's 1 over 2 times n minus 1 minus 1 over 2, and n minus 1 plus 2 is n plus 1. And this is 1 over 2n minus 1 over 2n plus 2. Okay, and the way it'll work is they'll all cancel out, and because we had the first 2 on the left, we'll have the last 2 on the right. Okay, and you can go back and do an n minus 2 and an n minus 3 if you want to check that they cancel here and here. Okay, which they will. So now we've got the sum of 1 over r plus 2 between 1 and n is equal to 1 over 2 plus 1 over 4 minus 1 over 2n plus 1 minus 1 over 2n plus 2. Now looking at this, okay, before we do it, let's make this 3/4 because that'll make it a little bit easier. So we're going to have 4 n plus 1, n plus 2 is going to be my common denominator here. So that's going to be 3 times n plus 1, n plus 2 minus, now this is going to be 2 times n plus 2 minus 2 times n plus 1. So that's 3n squared plus 3n plus 2 minus 2n minus 4 minus 2n minus 2 all over 4n plus 1 n plus 2. So that is 3n squared plus 9n plus 6 minus 4n minus 6 over 4n plus 1 n plus 2. So that's 3n squared plus 5n over 4n plus 1 n plus 2. I can take an n out, so that's n 3n plus 5 over 4n plus 1 n plus 2. And that is question 2 complete. Now let's move on to number 3. Okay, so this one I'll do without doing the pattern first of all. So I'll let f of r equal r minus 1 squared. So my sum is, f of r plus 2 minus f of r. So this now has 2 difference in it, so it's going to be 4 terms in total, but this is the other way around to what we looked at earlier. Okay, so it's going to be f of r plus 2 plus f of r plus 1 minus f of 2 minus f of 1. And sorry, it should be n plus 2, n plus 1 there. So what we've got is, if I substitute n plus 2 into my r minus 1 squared, n plus 2 minus 1 is n plus 1 squared plus n squared minus 2 minus 1 is 1 squared minus 0 squared. So I'm left with n plus 1 squared plus n squared minus 1. Which is n squared plus 2n plus 1 plus n squared minus 1. The 1's will cancel, leaving me 2n squared plus 2n. So I can take 2n out, leaving me with n plus 1. Now, if I compare to up here, therefore a equals 2. So that is the quickest and easiest way to do this. Of course, we can just do the full method of differences, which I'll do now. So that would mean the sum between 1 and n of r plus 1 squared minus r minus 1 squared. So substituting r equals 1 in, we get 2 squared minus 0 squared. Substituting r equals 2 in, we get 3 squared minus 1 squared. R equals 3n, we get 4 squared minus 2 squared. We're starting to see a pattern. R equals 4n, we get 5 squared minus 3 squared, and so on. Now the pattern here is, here's the 3 and this 3. Okay, this 2 and this 2. So the 2's, the 3's, the 4's will go there, and then the 5's and so on. So we're left with these two here. So now we need to do the n minus 1, and we need to do the nth term, so the final two terms. So r n minus 1, so n minus 1 plus 1 squared is n squared, minus n minus 1 minus 1 is n minus 2 squared, and n plus 1 squared minus n minus 1 squared. Okay, so these will cancel, okay, with previous ones here. You can see the pattern on this side, n plus 1. The one before it would be an n minus 1, which will cancel with that. The one before that would be an n minus 2, which will cancel with that. So it's these two that we want. So this becomes n squared plus n plus 1 squared minus 0 squared minus 1 squared, which is what we had. So n squared plus 2n plus 1 minus 1 is 2n squared plus 2n is 2n, n plus 1, therefore a equals 2. Okay, so exactly the same outcome there, whichever way you do it. Okay, let's move on to the fourth and final question. So first part is partial fractions. So that's a over 2r plus 1 plus b over 2r plus 5. Okay, so now I'm going to substitute r equals minus 5 over 2. So that'll be 4. That's going to be 0 plus b times by, now 2 times by 5 over 2, or negative 5 over 2, is negative 5, plus 1 is negative 4. So 4 equals minus 4b, so b equals negative 1. And then r equals minus r half. So that's 4 equals, right, a times, so minus a half times 2 is minus 1, plus 5 is 4, so a equals 1. So we've got that this equals 1 over 2r plus 1 minus 1 over 2r plus 5. Okay, so that's now what I'm going to use for my method of differences. So we'll use our standard method of looking for the patterns. So this is 1 over 2 plus 1 minus 1 over 2 plus 5. Substituting 2 in, 1 over 4 plus 1 minus 1 over 4 plus 5. Substituting 3 in, 1 over 6 plus 1 minus 1 over 6 plus 5. Substituting 4 in, 1 over 8 plus 1 minus 1 over 8 plus 5. Now in this case I'm not going to find the pattern unless I work these out. So that is 3. This one is 7, 9, 5, 7, 11, 9, 13 and so on. Now I can spot the pattern. So 1 over 7, 1 over 7, 1 over 9, 1 over 9, 1 over 11, 1 over 11 will be the next one. So we've got these two, front two here. Okay, so now if we look at the next set of the patterns, we're going to need the last two, so r equals n minus 1. So that will be 1 over 2n minus 1 and 1 over 2n, so plus 3. And then r equals n, 1 over 2n plus 1 minus 1 over 2n plus 5. Okay, and since the first two on the left were untouched, it'll be the last two on the right. So now we've got that our sum of 4 over 2r plus 1 and 2r plus 5 is equal to 1/3 plus 1/5 minus 1 over 2n plus 3 minus 1 over 2n plus 5. So this is 8/15. So this is all over going to be over 15, 2n plus 3, 2n plus 5. And it's going to be 8 times 2n plus 3, 2n plus 5, minus 15 times 2n plus 5, minus 15 times 2n plus 3. Now I'll expand this in one go. And there we have it. But after doing all this, I realized how pointless this is. So let's rub all this out. And let's go back up to just this point here. So we got that this is 8/15 minus 1 over 2n plus 3 minus 1 over 2n plus 5. Now, if we want to do between 16 and 25 of this, we want to do between 1 and 25 minus between 1 and 15. So that is 8 over 15 minus, so sticking 25 in here, we got 1 over 53 minus 1 over 55 minus 8 over 15 minus 1 over 33 minus 1 over 35. So that's put in 25 into here and then put in 15 into here for this one. So the 8 over 15's cancel and we get 1 over 33 plus 1 over 35 minus 1 over 53 minus 1 over 55. And then sticking that in my calculator, I get 1336, so 1336 over 61,215, but we want it to 4 decimal places, So that's 0.0218. Correct the 4 decimal places as required. So I went a little bit kind of off topic, going a lot further than I needed to. But from here, that is how we could do it. Alternatively, we could do it using the other method, you know, letting f of r equal one of these and then finding it out that way. But I'm not going to do it that way now. I'll leave you to have a go at it. Have a go at doing it the other way if you want and see if you get the same answer in the end. So that's it for this video, and it is it for this chapter. It's just one little part of this chapter. So in the next video, we'll move on to complex numbers. So stay tuned for that. And again, like if you've found this video useful, subscribe if you're yet to, and hit the join button if you're willing and able to help me out financially. Also, feel free to comment down below, especially if I made any mistakes or if you found easier ways of doing it. I'd love to know alternative methods to the ones that I've shown. Okay, so stay tuned for the upcoming videos on complex numbers.